Student researchers and fellow researchers. I am going to discuss chi-square measures of association and test. There are cases when the measures of your variables cannot be averaged or have nominal values, such as sex, color, attendance, preferred type of music, and preferred type of food, such as you cannot measure relationships using Pearson R. In such cases, you will have to employ chi-square based measures of association and chi-square test. Take note that chi-square measures of association have two kinds. One is the descriptive, where you simply determine the magnitude of association, and you use this to a non-probability sample or to an entire population. By the way, the descriptor of a sample is called a statistic, and the descriptor of an entire population is called a parameter. In inferential, it includes the test of significance of the association, which is applied to a probability sample. That is to find out if the observed magnitude of association in the sample would more likely be observed in the population represented, or if the statistic, the data from the sample, could be used to describe an entire population. These are the chi-square based measures of association for some of them. One is phi coefficient, and as you can see, the formula requires the value of the computed chi-square. Another is the Kramer's V, and likewise, the formula shown requires the computed value of chi-square. That is why it is called chi-square based measures of association. For the test of significance of the association, we use chi-square test. It is a tool to test no dependency or no association or independency between two variables. In Excel, when you use chi-test, it actually results to the determination of the level of significance. When the level of significance alpha is greater than 0.05, the null hypothesis of no dependency or no association is accepted. But when the level of significance alpha is less than or equal to 0.05, the null hypothesis is rejected, and the alternative hypothesis of dependency or association between the variables is accepted. It is therefore necessary that we determine the value of the computed chi-square, and its formula is, it is the sum of the difference between the observed frequency and the expected frequency squared divided by the expected frequency. And the observed frequency is the set of data that you have collected, and this is shown in the table of observed frequencies, while the expected frequency is equal to the rows total times columns total divided by the grand total in the table of observed frequencies. So let us assume we conducted a study. If the type of respondent is associated to one's preferred type of music and the collected data are shown below, we call the table as the table of observed frequencies. We shall calculate now the columns total and the rows total. We now have calculated the totals of all the rows and all the columns, which also give us the grand total of 915. We shall use the rows total, columns total, and the grand total in the table of observed frequencies to calculate for our table of expected frequencies, where for each box of observed frequency, a corresponding box for expected frequency shall be determined using, once again, the formula expected frequency is equal to the rows total times the columns total divided by the grand total. So in your Excel sheet, you have to draw the table of expected frequencies. Take note of the codes for the column and for the rows. For example, here you see table of expected frequencies started at A7. In the student rock cell, which is on B9, type equals B5 asterisk F2 slash F5. In the standby hip hop box or F11, type equals E5 asterisk F4 slash F5, where you come up with the values 96.612 and 89.1803 respectively. If you repeat the procedure in all boxes, you shall arrive at our complete table of expected frequencies. Let us identify the boxes where we placed observed and expected frequencies, because for each box, we have to determine the difference between the observed and the expected. So for box 1, we have 100 observed and 96.612 expected, until we reach box 12 with 100 and 104.918. We shall use the data to prepare a parallel table for the sum of the square of the difference OF minus EF and divided by EF, starting at B13 as our label and at B14 for the computations. For example, in B14, we type open parentheses B2 minus B9 close parentheses caret 2 slash B9. And we shall continue the process until box E16, where we will type equals open parenthesis E4 minus E11 close parenthesis caret 2 slash E11. Your result will be to get the sum of OF minus EF squared divided by EM. So in C17 type equals sum B14 colon E16, which gives 23.3675. For the computation of phi, type in B24 shown on the picture of Excel sheet on the screen equals B22 slash B23 and type in B25 equals B24 caret 0.5 to get the value of 0.15981. Assuming that our sample size 915 is a probability sample, we can now know if the phi value of 0.15981 from our sample would more likely be observed in the population the sample represents by applying the chi-square test. So using Excel for the chi-square test of significance of association, you click formulas, more functions, statistical, and chi-SQ test. So this box will appear. The actual range of frequencies is B2 colon E4. So include it in the actual range array. The expected range is B9 colon E11. Encode it in the expected range. Click E13 for the output level of significance alpha and click OK. If alpha is greater than 0.05, accept the null hypothesis of no significant dependence or no significant association. If alpha is less than or equal to 0.05, reject the null hypothesis of no significant dependence or no significant association and accept the alternative hypothesis of significant dependence or significant association. Since alpha, the result of our p-test, chi-square test in Excel is 0.00068, which is less than 0.05, we reject the null hypothesis of no significant association and accept the alternative hypothesis of significant association. This means that the value of phi, which is 0.15981, although very weak in magnitude observed in the sample, is significant or would more likely be observed in the population. So today, my student researchers and fellow researchers, I hope you have learned something about the use of chi-square for measuring the magnitude of association through phi coefficient and testing the significance of association using chi-square test. Thank you for viewing and listening.